Ready. Okay, start the clock now. So guys, today what we're going to do is we are going to teach you a skill. There's nothing to understand. This is simply monkey see, no offense, monkey do. Guys, I am teaching you a skill that you need to be able to get your arms around for the rest of the year. So there's nothing conceptual, there's no ideas, it's just be able to do this and then get really fast at it. So, what is it that you need to be able to do? And guys, the answer is this. You've got to learn to calculate what are called formula masses. Now, along the way, getting ready for what's going to happen on Thursday, we're going to take this advantage to talk really quickly about significant digits. Now, guys, do you remember when we did this in August? And do you remember that a lot of you had physics and you guys all had really negative impressions of significant digits, and then I tricked you into liking them? Remember that? I'm going to do the same thing on dimensional analysis on Thursday. So, but that said, let's make sure you're clear on significant digits. So guys, I'm not going to give you time to write this down. The reason is twofold. One, this is all out of your notes. And if you can't find it in your notes, just get on our website and print this page. So we're not going to spend the time to do this in depth. I just want to remind you. So guys, we talked about significant digits on August 21st. So if you need to go back and look or review the homework, go back to August 21st. So guys, again, significant digits tell us accuracy, and there are three types of significant digits. Non-zeros, final zeros after the decimal, and trap zeros. Guys, rule number 4 we really don't need because it tells us nothing else counts. So if that is not familiar to you, guys, go back to August 21st, maybe print the homework. Heaven forbid you would do this without getting credit for it. But guys, go back, look over the homework from the 21st, make sure that you can identify significant digits. Then we talked about rounding. We actually did this before this on the 19th. But guys, throughout that first unit, we talked about rounding rules. And guys, if you remember, the rules for multiplication and division are different than addition and subtraction. Remember that? Multiplication and division, you round to the least accurate factor, so the fewest significant digits. And then with addition and subtraction, you don't care about significant digits, you round to the fewest decimal places. So, guys, if any of this is fuzzy for you, you've got to bring that back to your memory for Thursday, so go back and look at that if you need. Groovy? Okay, so guys, what do you need to learn how to do today? And the answer is this. This is where you want to start taking notes. Guys, what you're going to learn to do right now is calculate formula mass. So to do that, what you've got to do is figure out what's called chemical composition. So the deal is this. Last time, you learned to write chemical formulas, right? You learned to do this for salts. You learned to do it for molecules. You understand the prefixes, the Roman numerals, the least common multiples, the parentheses, all of that stuff. Well, guys, today what you're going to do is you're going to learn to calculate the masses for these compounds. So how does this go? Well, guys, first thing we've got to learn to do is break these compounds down into their elements. So here's an example. This you want to write down with me. I know that this is all conversational, but you do want examples today. So guys, grab your periodic tables, grab your ion charts. And let's talk really quickly. Guys, what is this compound? First of all, is it a salt or a molecule? It's a salt. How do you know? How do we know it's ionic? Magnesium is a metal. And anytime we've got a metal first, we know that it's a salt because those form ions. So guys, this is a salt. What is the name of this salt? Magnesium phosphate. But guys, that's not the point of what we're doing today. The point of what we're doing today is figuring out what magnesium phosphate is made of at the elemental level. So guys, how many different elements, remember elements, how many different elements are in magnesium phosphate? 3. Magnesium, phosphorus, and oxygen. So guys, this represents magnesium atoms, phosphorus atoms, and oxygen atoms. Now guys, what I would do is abbreviate those. So it is important that we know how many, but it's also important, or I'm sorry, let me say that differently. It's important that we know what, but it's also important that we know how many. And guys, the only thing that makes this tricky is the parentheses. How are we doing on time, Paxton? Good, now I have all the time. All right, here we go. So guys, magnesium. How many magnesiums are in a magnesium phosphate? 3, right? The subscript tells us there's 3. Now guys, this is the only thing that makes this tricky. Now we go over here and we look at phosphate. Phosphate is 1 phosphorus and 4 oxygens, right? But how many phosphates are there? There's 2. So how many total phosphorus atoms are there? 2, because there's 1 in each phosphate, but there's 2 phosphates. And if you understand that idea, you can then tell me there's how many oxygen atoms? 8, right? Because of 4 times 2. You get the idea? Pretty straightforward. Okay, so guys, if you can do that, do this. Figure out how many atoms there are in a iron 3 sulfate salt. And if you're looking at this and going, wait a minute, this is Fe2SO43, and Knappenberger just called it iron 3 sulfate, you probably need to retake the test. Because guys, the Roman numeral doesn't tell you how many, it tells you the charge. So this is in fact iron 3 sulfate. But independent of that, what I'd like you to do right now is figure out how many of each atom is in iron 3 sulfate. Were we 5 minutes in or 5 minutes left? Oh, money. We got this. So guys, I think you've probably figured this out by now. This is composed of iron atoms, sulfur atoms, and oxygen atoms. The question is how many of each? So let's pick it apart. Guys, iron is Fe. Iron is Fe because the Latin for iron is ferrium. Thus the abbreviation doesn't matter. So guys, how many iron atoms are in this compound? 2. How many sulfur atoms are in this compound? 3, right? Because there's 1 in each SO4, but there's 3 SO4s. 1 times 3 is, of course, 3. And then how many oxygens? An even dozen. You get the idea? Okay. Now, guys, this skill is actually a step towards what you're going to learn to do today, and we really are almost done. Because guys, what you're going to learn to do today is figure out what are called formula masses. These are the terms you need to know. It's not confusing, but it's a little weird. Guys, you're going to learn to calculate what are called formula masses. But when we talk about formula masses, we call them formula masses if it's for a salt. If it's a molecule, we call it a molecular mass. They're calculated the same, everything works the same. We just use a different term because salts don't exist as molecules. So the bottom line is this: whether it's a salt, which is a formula mass, or a molecule, which is a molecular mass, what we are talking about is the mass of one formula unit of the compound. And guys, these formula units will always be given, these masses will always be given in AMUs. Remember those? Atomic mass units. You are now done taking notes. We're going to look at 2 examples and then you're going to get your homework done today. While you guys are doing this, writing this down, let me ask you a question. Who stole my periodic tables? When you guys took the test with Lawson, I left out a stack of periodic tables thinking somebody would probably forget one, and you know that I'll lend them to you for points, but I didn't want to put Lawson in the position of having to do the points thing. So I set out a stack of periodic tables, came back on Monday. I have no periodic tables. So guys, some of you apparently figured rather than those being available to borrow, they were like party favors. Who's got my periodic tables? No? All right, you should have had your own. Who's got? So guys, you'll know it's not yours because it says Knappenberger across the top. All right. I'm not trying to make you feel guilty. I just want my tables back. All right. So guys, caught up with me? I wouldn't. He's a slimy dude that way. All right. So guys, let's review really quickly. Okay, set the Wayback Machine to September, which is when we learned about atomic mass units. You may remember that the atomic mass unit is the mass of a proton or a neutron, and we talked about atomic mass units when we figured out the masses of atoms. And where did we find the mass of an atom in atomic mass units? On the periodic table. So grab your periodic tables, refamiliarize yourself with where these masses are on the periodic table. What color are they? Red. They're the little itty bitty red numbers. You may remember that they are not whole numbers because they are the averages of all the isotopes of these compounds that exist. Is it starting to come back to you? Okay, so guys, all of those masses on the periodic table are in AMUs. Some of you right now then see where this is headed. See guys, what we can do is we can take the stuff that you just learned to do, how many iron, sulfurs, and oxygens in iron 3 sulfate, we can marry that together with the masses that are on the periodic table, and we can now figure out the formula masses for molecules and salts. So how does this work? Well, guys, join me here. This is what you're learning to do today. Sodium phosphate. I'm sort of stuck on phosphate, apparently. So let's make sure you're good on what you just learned to do. How many sodiums in sodium phosphate? 3, write it down. How many phosphoruses in sodium phosphate? 1, but what about the 4? That's only for the oxygen. So there's 1 phosphate, and then how many oxygens? 4. Now, we want to figure out how much this sodium phosphate, we want to figure out how much that weighs. So what do we need to know in order to figure out how much sodium phosphate weighs? The mass of sodium, phosphorus, and oxygen. Now guys, here's what we're going to do. We're going to go 1 decimal place. Round your masses to 1 decimal place. That is not a universal rule. You will learn the rules on Monday of next week. But guys, for now, we're going to go 1 decimal place. So what is the mass of sodium to 1 decimal place? 23.0. What is the mass of phosphorus to 1 decimal place? I don't even remember. 31.0. But guys, notice what we're doing with these. If sodium weighs 23 and there's 3 of them, multiply it and that's 69. If phosphorus weighs 31 and there's only 1, that's 31. And then guys, what does oxygen weigh? 16.0. 4 times 16 is 64. Notice guys that I'm labeling my numbers. You can label these as AMUs or just U's. And now guys, what do we have to do to figure out the mass of sodium phosphate? Add all of these together and it's 164 atomic mass units. You get the idea? 1 more to go. Questions? Because guys, this is your homework. If you can do this, you can do the homework with 1 little twist. I know. You good? Okay, so we're going to do 1 more together, and then you'll have time to do your homework. Can I go? What about this? You're good, right? Because you guys told me at the beginning of the day you did well on the test. But guys, the bottom line is this, and I know I opened with this. You okay? Guys, if you can't do what we're about to do together, you've got to get this figured out. It's not going to go away. Forgive me, but this will be crippling for you. If you cannot write chemical formulas, you are not currently okay. We can help you, but you're not okay, and you've got to step up and get help. So guys, Chromium III Sulfate. We need to write its chemical formula, so the first thing that we need are the abbreviations. So chromium is Cr, but we need its charge. And we don't even have to look because the Roman numeral tells us it's +3. Then we need sulfate. You'll notice I've come back to sulfate just like I came back to phosphate because we've already looked at sulfate. We remember that sulfate, being an 8, is a polyatomic. It's SO4 and its charge is -2. Now guys, I know for the most part you're comfortable with this, but where do 3 and 2 meet up? 6. So how many CRs do we need? 2. How many SO4s do we need? 3. And it looks like this. That is chromium III sulfate. Now that we're at this point, we can now go through the process that you said you were comfortable with previously. So we've got 2 chromiums. And we've got 3 sulfurs. And maybe I went too fast. Are you okay with 3 sulfurs? And we've got 12 oxygens. So now, guys, we've got to figure out what chromium weighs, and I have no idea. I'm going 52.0. Then we do that math. 2 times 52 is 104. Sulfur, I actually know. Sulfur, I believe, is it 32.1? Is that right? So, guys, sulfur to 1 decimal place is 32.1. Do be careful when you round. Make sure you're rounding to 1 decimal place. Doing that math, we get 96.3. Go ahead. No? Isn't that interesting? Not always, but the thing that's odd, not odd, it's kind of cool, is if you look at these polyatomics, almost all of them have oxygen in them. Isn't that interesting? But no, they don't, but that said, a lot of them will, just because a lot of them will be polyatomic salts, and a lot of these have oxygen. Yeah, it's neat you've picked up on that. Speaking of oxygen, guys, oxygen has a mass of 16. 12 times 16 is 192. And then, guys, we do the math. And again, remember, we are observing significant digit rules here in that we're conserving decimal places, and the mass of this is 392.3. Okay. Now, guys, with this said, how are we going to approach the homework? And guys, here's what you're going to see. And well, you've got the homework in front of you. Grab it. So guys, follow along so that you understand the expectations. Because the expectations have nothing to do with the answers that I've posted. So here's the deal. If you look at the homework, you're given the name of the compound. You are given a space to write the formula, and then you are given a space to write the mass. Guys, I would love it if you could show no work and get the right answers. I know that sounds weird coming from me because I'm always about show your work, right? But guys, you got to understand that what you're doing today in homework is such a small piece of such a big, big concept that this has got to become automatic for you. So guys, you're welcome to show whatever work you feel you need to. And you'll notice in the answer key, which is up here, I went through this in very great detail so that you have something to look at if you get lost. But guys, if you can just simply write down the formula and then write down this without any of this work, that's the best. And eventually you've got to get there. But if you want to spend the time and show all this work on another sheet of paper, that's fine. But if you can do it without, that's better. So guys, how'd I do? 3 minutes over. All right. Guys, the rest of the time is yours. We will grade this on Thursday. Please come in on Thursday with an open mind, because in the same way that I tricked you into not hating significant digits, I think I can probably help you come to appreciate dimensional analysis. So get this done. We'll go on Thursday.